Alright guys, so let's go ahead and move on. I just turned to a new page so we can start for today's lessons. So as you can see today, we're going to be talking about roots of a parabola in more detail. And the guiding question will be really this, like how to tell how many roots a quadratic will have if we just have this equation y equals ax squared plus bx plus c. And we don't have a picture. Again, a picture is really easy. You can just spot it. In here, how can we tell information without having to graph it? Because as you'll see tomorrow, it could be a little hard to graph these things. So, to answer this question, we have this general form of a quadratic, y equals ax squared plus bx plus c. And this covers both positive and negatives. It depends on what a is. So, to actually know how many roots we have, we're going to use what is called a discriminant. So discriminant. Now I know what you're thinking, it's not what you think. This is talking about a mathematical discriminant. It has a formula. And here's what it is. So the formula is b squared minus 4ac. So the discriminant is right here. And here's the formula. So this is the big thing for today. Formula is b squared minus 4ac. That's the discriminant, okay? Now, if this is this should be ringing a bell. If not, let me ask you, where have you seen this before? Now, if you don't remember, let me go ahead and give it to you guys because we have to move on. But let me go back to the quadratic formula. And if you remember correctly, the formula for this was x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So again, this is like the opposite of whatever b is, plus or minus the square root of this whole thing. So notice that the discriminant, it's specifically taking this value inside of here and finding whatever that is. This is going to tell us so much more information. So from the quadratic formula, this right here is the discriminant. And the reason why we use discriminant is because we have different cases. So if we actually try to plug in on a calculator the different cases that we have here, like a negative number, positive number, or 0, you'll see how this applies to the number of roots we have.